We've all heard the term greenhouse effect, but how many of us can really explain what it means? Do we know why carbon dioxide has such a critical influence on the Earth's climate? Do we know the main sources of this carbon dioxide? Join us now in an exploration of these and other questions. If there's one term connected to climate change that we've all heard over the past decade or two, it's the greenhouse effect. Cartoonists are fond of drawing the Earth encased in a greenhouse when they want to make a point about climate change. But while the term, which goes back to the 1820s, is familiar, a good many of us don't actually know what it means and why it's important. Climate change starts with our atmosphere, the combination of gases surrounding the Earth without which this planet would be a large, lifeless sphere. And we wouldn't exist. While many processes in the Earth's atmosphere occur naturally, it's the measured rate at which some are changing that is a major cause of concern. In the case of greenhouse gases, some, like carbon dioxide, have been increasing at a rapid pace. But other gases, like water vapor, play a crucial role as well. Since the 19th century, when the first and largely theoretical research was done, scientists are now able to define with increasing precision the impact that such gases are having on changing Earth's climate. The result of their findings? Global warming is occurring, and greenhouse gases, added to the atmosphere, are driving it. Over the last 130 years, global temperature has risen almost 1 degree Celsius. But how do we know for sure? Global mean temperatures are based on millions of measurements made at thousands of weather stations globally and averaged over much of the face of the planet. In this graph, the black squares refer to annual averages, while the red line is a 5-year moving average. The data are presented as the temperature change in any given year, the so-called temperature anomaly, relative to a baseline. In this case, the baseline is the average global temperature over the 30 years between 1951 and 1980. Note the vertical green bars. They show the estimated range in the uncertainty of the analysis. Uncertainty has been decreasing over the last century as our measurements have become more and more sophisticated and data analysis has become more statistically rigorous. Since the mid-1970s, there has been a relatively steady rise in global average temperature. Experts in the statistics of global change require a minimum of 30 years of data to define a climate trend. Using that yardstick, you can see that every decade since the 1970s has been warmer than its predecessor. Indeed, 2000 to 2010 was the warmest decade in recorded human history. So what is causing this rise in temperature? Let's begin our discussion by looking at the big one, carbon dioxide, and the critical influence it has on the Earth's climate. What we see here is the Sun's relationship to the Earth and the Earth's atmosphere. The Sun has a surface temperature of about 6,000 degrees Celsius, and it radiates huge amounts of energy down toward the Earth, most of it as visible light or short-wave radiation. The gases that make up our atmosphere, mostly nitrogen and oxygen, but also carbon dioxide, are largely transparent to short-wave radiation. About half of the incoming shortwave gets reflected back to space by the tops of clouds or by light-colored reflective surfaces like ice caps or desert sands. The other half warms the Earth's surface, which then radiates energy back towards space. But here's the rub. That outgoing radiation occurs in a different form called infrared or long-wave radiation. The atmosphere is not transparent to that outgoing infrared energy. Carbon dioxide molecules in fact absorb it, hold on to the energy for a moment, and then re-emit it. Some of that re-emission comes right back down at us as heat. Some is reabsorbed by other greenhouse gas molecules, and some eventually escapes to space. This chain of absorption and re-emission temporarily traps energy in the Earth's atmosphere, and it is this energy that has helped keep the Earth warm. Without this naturally occurring process, the Earth would be considerably cooler everywhere. But if we add more carbon dioxide molecules to the atmosphere, as we've been doing for decades now, these extra molecules increase the interception of outgoing long-wave radiation, thereby retaining additional heat and thus contributing to a more intense warming of the planet. So what has actually been happening to the concentration of CO2 in the Earth's atmosphere? How do we know? Can it be measured? In the late 1950s, an American scientist, Charles David Keeling, developed an instrument that allowed him to measure carbon dioxide concentrations in the atmosphere very accurately. Within a few years, he was able to prove without doubt that CO2 levels were increasing. This graph shows the result of Dr. Keeling's findings. These measurements were made at the Mauna Loa Observatory in Hawaii, a high-altitude site that offers a well-mixed portion of the atmosphere in the middle of the Pacific Ocean, far away from automobile tailpipes and fossil fuel-burning power plants. When Dr. Keeling began making these measurements in 1958, the carbon dioxide concentration in the atmosphere was 315 parts per million by volume. That is, 315 liters of carbon dioxide per 1 million liters of air. Today, the concentration exceeds 390 parts per million, nearly a 30% increase in just half a century. The source of the increased CO2 levels is us. We know this because the added CO2 carries with it chemical fingerprints that very clearly point to the combustion of fossil fuels as the primary contributor of the additional carbon dioxide that is being added to the atmosphere. We use fossil fuels to generate electricity, power our vehicles, heat our homes and offices, and power much of our industrial economy. But what amount of CO2 addition does each of these human activities account for in our atmosphere? Globally, heavy industry, for example, the manufacture of products like cement, steel, and consumer goods, accounts for nearly 1/5 of the CO2 addition. Residential and commercial electricity production accounts for roughly 2/5, and deforestation accounts for another 1/5, as lost forests no longer take up CO2 from the air. The transportation of goods between and across continents and increased automobile use account for most of the remainder. What we have seen from the work of Dr. Keeling and others is that greenhouse gases, especially increased concentrations of carbon dioxide, are contributing to global warming to the extent that global temperature has risen almost 1 degree Celsius over the last 130 years. The burning of fossil fuels on which we are dependent is a main cause. Changing the way we produce and use energy is therefore a major challenge, and one we need to address if we are to limit the amount of warming that human activities are causing.